So, I think where we left off last time, we were messing around with our prototype under actor. So inside here, we built a rule. So that was our equivalent of an if statement asking questions from a language like Java. So here's what an if statement looks like in Java. We ask a question based on a Boolean expression. What's a Boolean expression? Any expression that boils down to a single value of true or false. When this Boolean expression is true, do this crap. Otherwise, do this crap. Okay? So again, programming languages try to simulate the way human beings solve problems. Java does it this way. Game Salad, I don't know if it's fair to call it a programming language, but it's a game engine that kind of has a visual language built into it, so it's at least a sort of a programming language. They have a facility for simulating asking questions through something called a rule. So in a rule, we can ask a question. So we're asking, is this dude, and we're going to talk about self a little bit today, is this dude, is his attribute mynum less than 5? If it is, we're going to display the text mynum. We'll display whatever the number is. Otherwise, so here's our else, and else's are optional. Display boo. All right? And right now we have mynum set at 3, and that is for all instances of this particular actor. Okay? So, since it's set up to 3, both of these guys will have it set at 3. They should both show 3. Because that's what the if statement said to do. That's what the rule said to do. It said if it's less than 5, display the number. All right? But if we go into the blueprint, we change this guy to 7, play again, we get blue. We get boo. Make sense? All right, so let's give us a little bit more Java context for this. Again, I'm going to show you lots of examples in Java, but I'll never test you in Java stuff in here. You'll get plenty of that next semester. So really, I'm just trying to connect the dots. All right, so I'm going to go ahead and just create a quick little project in here for this class. Nope, sorry. Okay. So I created a program here, and it has something in it called scene. So that's kind of like Game Salad here, where everything is based in a scene. So we're in our one default scene right now called initial scene. And inside scene, I'll go ahead and I'm going to create an integer called mynum. We'll start this guy off at 3. And then I'll just output to the screen real quick whatever mynum is. So when I run this program, we should see a 3 displayed to the screen. Okay? Now, let's create the equivalent of what we are doing inside of Game Salad right now. So I'm going to come in here, I'm going to create a new actor. Or in Java, these are called classes. Okay, so I'm going to create a new class. I'm going to name this guy Actor1, just so it matches up to what we've been doing in Game Salad. And Actor1 is going to have a whole bunch of attributes we see inside of Game Salad. Under Actor1, here's all the attributes this guy has. Okay, so a bunch of them came with the actor built in. I'm just going to add one additional one, which is the one we added, mynum. That's an integer. Okay, so I'm going to say that this actor has an int associated with it called mynum. Okay. And then we're going to have a We'll do it this way. Okay, so I built an actor. Built into this actor, we have a single attribute called mynum. I started it off as being 3. And then I just built in this method, don't worry about this too much, called display. Think of that method as being kind of equivalent to this whole area over here for us right now. And inside here, I just ask a question. If this.mynum is less than 5, then display this.mynum. Otherwise, display boot. Okay? Now, I'll go ahead and take these out for right now. Now let me do a couple things out here in GameSalad. Get rid of my 2 actors. If I run this GameSalad program right now, what will my output be? What will you see on the screen? Nothing, right? Okay, it's a blank scene, correct? Even though I have a blueprint over here for Actor 1. I haven't actually built any Actor 1s, correct? He exists. I can quickly build one of these guys just by dropping them in, but right now it does nothing. Similarly, in this Java program over here, I have this blueprint I wrote for Actor 1. And this guy has some logic in it. He has an extra attribute that he didn't initially come with. Just trust me on this. There's some things that are part of this guy that you don't actually see right now. We learn all about that next semester through this thing called inheritance and all this other crap. Not important for us right now, but we added our one unique attribute for actors. And then we added this little block of code to ask that question. Okay? But right now, so I'll just make a global statement. All programs begin and end with main. So every program you ever write, whether it's Java, C#, Objective-C, even older languages, will have in some form a main program, a main method. So for us, associated with this scene, when we hit play, this scene gets the ball rolling. So something behind the scenes here, inside this scene, there's a main. And main says, okay, here's my collection of actors. Let's go through each one of those guys and make them do whatever they're supposed to do when we hit play, all that stuff, okay? We don't see it, but it's there. Now, so if I run this program right now, since all programs begin and end with main, my output will be nothing, just like it is in GameSalad. So I'll hit play. I promise you I hit play. Nothing. So what we're going to do is we're going to go into GameSalad. We're going to drag an actor out here. Now when I hit play, I get the one guy says boo right now because I think I set my mynum to 7, right? All right. Similarly, in main, I can say actor 1, A1 is equal to a new actor 1, and then say A1 dot display. And just so our programs are equivalent right now, I'll go in and I'll change mynum to a 7, just like we have it in GameSalad. Okay? So what I did inside of main is I created an instance of my blueprint. Okay, so I created an actor, I named him A1, and then I told him to display himself, essentially calling his behavior list. Okay? Now when I run this guy, the output will be boo. Okay, just like this guy shows boo on the actor. Similarly, I can drag another one of these guys out here. Change nothing, now I get 2 boos. I can come into Java, I can use that exact same blueprint to create a second instance of my actor 1. And tell him to display himself. That makes sense? Oh, sorry. We'll hit play, and we'll see 2 boos. Okay? So, Java equivalent to what we're doing in Game Salad. Interestingly enough, notice that we're having to write a whole, I mean, this isn't all that intimidating worth of code, but this is harder to do than what we did over here. Create new attribute, drag a couple boxes around, done. KK, thanks. Right? All right. Oh, I don't have any coffee. Ooh. Okay, so, anyways. What I'm going to do here, well, first let me talk about a couple of things. Inside of this actor, notice when we display our text here, when we went through the little wizard they have to go and find mynum, so we went in there, we clicked on actor 1, scroll down, found mynum, and it says self.mynum. Self is how an instance of a blueprint refers to themselves. Okay, so if I am this guy, self.mynum is me. If I'm this guy, self.mynum is that guy. That makes sense? Okay? The equivalent in Java is the keyword this. So this is how an instance of a blueprint refers to themselves in Java. Okay? They're basically synonyms for each other, just to make the syntactic connection. All right. Now, as of right now, over in our Java program, every single actor we ever create will have an attribute named mynum, and it will always have the value of 7 in it, unless we come inside the actor blueprint and specifically hard-code it to something new. Make sense? So now if I run this program again, now it should say 3 instead of boo because we just changed it to something that's less than 5. Same thing happens out here. I go into my blueprint. I change this guy back to 3. Hit play, and now we have 2 3s. Now, ideally, when you have dudes in your video games, instances of these actors, while when we first create them, they might be identical to each other. Over time, we want these guys to become individuals, right? We want there to be a possibility that this guy's mynum is different than this guy's mynum, right? Okay, so how are we going to do that? Let's go into our actor. So we already have this rule in here that just asks, if the current value of mynum is less than 5, do this. Display it or say boo. Okay? So we're going to start this guy off at 0. So it should say it, right? I'm going to go ahead and create a new rule in here. And we're going to look at events a little bit. So if this actor, again, this is a specific instance of actor 1. So I'm editing the blueprint, but this guy will play out for this guy. It will also play out for this guy as individuals. Okay, so each of these 2 instances of actor 1 get their own version of all this crap. So I'm going to say if this particular instance receives the event, let's say touch, we'll do touch pressed. What are we going to do? We're going to change an attribute. The attribute we're going to change is this particular actor's mynum variable to be this particular actor's mynum variable plus 1. So every single time we tap on that guy, we want it to become 1 bigger than it used to be. Make sense? We'll go ahead and hit play. They both say 0. Now that says 1, that says 2, that says 3, that says 4. This guy says 1. Now we're into the boos. But it takes this guy a little bit to get into the boos. Make sense? Okay. The equivalent to that in Java is we'd come into our actor And I'm going to this is a little bit weird to implement in Java because this is kind of the reason why we need game engines. What I'm doing here. Maybe eventually I'll build something in here that'll be kind of cool that allow this to just keep working. But in any case, I'm going to create a little method in here called touch. And this guy will say this dot mynum is equal to this dot mynum plus 1. Okay, and then what he'll do is he'll go ahead and call this dot display. That'll fake it at least enough. Okay, so we create both of our actors. We ask them to display themselves. Okay, this does it one time. So there's our 2 3s. Oh, we're going to start off at 0 just like our program. Okay, now we'll run it, show there are 2 zeros. So we're going to say a1.touch, and let's just do that 3 times. Now, I made that method each time we call it to go ahead and display itself again. So when I first run this program, A1 should say 0, A2 should show 0, then we're going to touch A1 3 times. So we should see 1, 2, 3 appear to the screen. Just for A1. If I then say A2 dot touch, we should see a 1 for A2 at the end. Make sense? Okay, so the proof there is we used a single blueprint, this guy, to build 2 separate instances of that blueprint. Kind of like we were talking last time about every house in the same subdivision looking the same, although they're individual houses and they have different crap inside of them. Okay, so we used that blueprint to build 2 separate actors. And then we made those, told each of those actors to display themselves, and then we tapped on each one some number of times. Okay, just like we're doing out here in, we'll start this again. So these guys are separate. So notice when I click out here, nothing happens. But when I click on an individual actor, that is, this actor right here receives the event touch. This guy receives the event touch, touch, touch. Make sense? Okay. So that's how we can ask questions. Now, if we look at this inside of GameSalad, though, we notice that there is some sort of game loop going on in here. This rule only exists once. So I'll rename this rule to what should I display? That's what that rule is going to be. Okay? This rule is all about what I should display. This rule is, did somebody click on me? Okay, that's what that rule is. Now, when this guy first starts and nothing's happened, it just says 0, right? We haven't clicked. But as soon as I click, it became a 1 right away. What does that tell us? That tells us that it received this event, but immediately after I received that event, it executed this again. We have something in here called a game loop. Okay? There's a game loop where there's a period of time. Each of these guys lives inside of something called a thread. So let me talk about that for a second. So we have something called a thread. This is one of those examples where commonly books use the name of it to define it. It's a thread of execution. Basically, we want to think of this as a self-contained running program. with the idea being that if I have two separate actors, these guys are both running simultaneously. So in my game salad right now, if this is my current game, let's just assume there's probably more than 3 threads in existence right now, but just from a simplified perspective, we have 3 separate things going on. We have one thread, probably the default thread, governing the entire scene. So the black background here and anything else, anything that's happening inside of that. Then we have another thread that governs just this actor. And we have another thread that governs just this guy. And what that allows us to do is it allows us to be able to interact individually with elements of our scene and have those guys be able to respond individually. Otherwise, we run into a situation like this. Let's just say that this was non-threaded. It was linear. If that was the case, I might have to wait till this guy is clicked before I'm even allowed to click this guy. Does that make sense? Because this guy would block any events that this guy is waiting to receive. So by having it in threads, multiple things can happen simultaneously. And this is actually interesting. We take this for granted today, but historically, so life before threads. A good example of this would have been an older version of the Mac operating system, OS 8, OS 9. So before Mac OS X came out, they had something called their multitasking model was something called preemptive multitasking. So it kind of faked multitasking. How many of you have ever used a computer that didn't have multitasking? Can you even imagine not being able to check your email and have a web browser open at the same time? That used to be the norm. All right, but so early Macintosh computers, not that early, we're talking 12 years ago? 13 years ago? 14 years ago? I mean, not ridiculously long ago. So back then, the Mac operating system had something called preemptive multitasking. Fake multitasking is maybe a better term for it. So what would happen here is you would have your internet browser open. You would have, so maybe you started getting something downloading. Okay, back then you were downloading a 2 megabyte file, so it was going to take all day. All right, so you'd get something downloading in the background, then you'd switch over to Microsoft Word or whatever to write your paper because you're all studious, non-procrastinators, right?
Yeah, sure.
You work on your paper for 3 hours and you go back and you check on your download and recognize that it has barely made any progress. Okay, barely any progress. Why? It was given just enough CPU time to keep that process alive. It wasn't actually happening simultaneously. Now, having said that, we have these things called CPUs, processors, right? Now, most of our processors today have multiple cores in them, correct? What does that mean? What does it mean to have multiple cores, other than multiple cores is better than more cores is better than less cores? Is that the punchline? More cores better than less cores? Yeah. What does it mean, though, to have multiple cores in a processor? Nobody? No takers? How many of you have built your own computer? Okay, everybody who has their hand up should be able to answer this question. What does it mean to have multiple cores? Go ahead.
I don't have an exact answer, but I'm pretty sure it has something to do with multi-threading.
Yeah, you might think, considering it's on the same slide. Okay. Any more than that, or is that all you want to give me?
Just allow you to do more at once.
The more operations you can do at a time, the more cores it has.
Okay, so really it comes down to that. The number of cores a processor has is equal to the number of things that can technically happen simultaneously. So if you have a quad-core processor, Only if the operating system schedules it correctly, you could potentially do 4 things literally simultaneously. The best way to talk about threads, though, is in the world of single-core processors. Multi-core processors are also much, much, much more difficult to schedule for, so the operating systems get a lot more complex if you're dealing with multi-core. So just because you have a 4-core processor doesn't mean your computer is 4 times faster. It's still reliant on whether or not the things you are currently using your computer for can be split into multiple tasks. This kind of goes down to how many people does it take to change a light bulb. So let's say I can change a light bulb at 3 gigahertz, and I'm a single core processor. And we're dealing with a 64 core processor, the rest of you, and you can change a light bulb at 2.93 gigahertz each core. Who's going to win at changing this light bulb? I will, because I can change a light bulb faster than any individual core can. And light bulb, one-man job. Correct? But let's say that we were going to clean up a park. So we had to rake leaves for a park or something like that. And let's say I could rake leaves at 3 gigahertz. And I was competing against a 8-core processor that could rake leaves at 2.5 gigahertz per core. So I'm substantially faster than any individual. But don't you think those 8 people are going to be able to rake the leaves in that park quicker than that one person can, even if he's faster in and of himself? Yeah, absolutely. That's the advantage of multi-cores versus single core. Okay, now the example of threading here makes the most sense when I talk about single core processors, because with a single core processor, as he pointed out, whether it seems like this or not, literally only one thing can happen at a time. Now the idea is that your processor is so fast that it fakes us out. We think everything's happening simultaneously, but it's actually working a little bit here, and 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 then zipping back around, and we don't know any difference, right? Everything's happening so quickly that we don't know what's going on. Threads are a way for an individual program to fake having multiple things happening at once as well. So let's say you have 5 programs running on your computer. Each of those individual programs is getting scheduled for CPU time. So the first program might get 100 cycles on the CPU. The second one might get 100 cycles on the CPU. The third one might get 100 cycles on the CPU, so on and so forth. Well, that first program is getting 100 cycles on the CPU. It can either use those linearly and just do this, then this, then this, then this, then this, or it can internally decide, I am going to share my 100 cycles on the CPU. I'm going to split it up amongst 4 threads. And each of those 4 threads is going to get 25 cycles. So maybe you work on this thread a little bit, then this thread a little bit, then this thread a little bit, then this thread a little bit, and zip back around. So it internally, while you're running your program, seems like multiple things are happening at the same time in your program, i.e. Microsoft Word with the little paperclip guy dancing on the bottom. Remember him? Is that before? Everybody remembers him. Okay. So that's 2 things happening at once, right? You got the little cursor blinking, you got paperclip guy dancing. 2 things at once. Okay? It wasn't technically happening at once if you were on a single core processor, which I think only existed back then. But it felt to us like it was, because it was happening so quickly that from our perspective, everything was simultaneous. Make sense? Okay, so multi-threading allows more than one thing to seemingly occur at the same time within a single processor, within a single program. Okay? Now, to take that to the next step, if you have a multi-core processor that is working on a program that was designed to take advantage of multi-core processing, you might have a single program that's equally using all 4 of your cores. And each of those 4 cores, and each of those sub-processes, child processes of your big program, is also spawning off threads to share that time. You could have one program that has a whole bunch of little worker bees working inside of it, seemingly happening at the same time, only of which 4 could actually be happening simultaneously. Does that make sense in a quad core? Okay, so that's kind of what's going on inside of a game engine. So when the more things we get on the screen here, the more bogged down our game's going to get, because the more it's having to fake us out. So if we just keep spitting out actors, our game's going to start getting really, really, really slow. So kind of makes sense there. What's going on? So the idea here is that there is a thread of execution associated with our actor. And this guy, and probably there's groups of actors that all belong to a single thread, rather than if you have 4 million actors on the screen and each actor gets its own thread, then your whole game might get bogged down. So you probably have thread groups where maybe 100 actors, or let's just say, get assigned to a single thread group. And each of those guys is on the, process him, process him, process him, process him, process him, and so on and so forth. And what does it mean to process an actor? Go through his game loop. So this is called the game loop right here. Start at the top, keep going down, loop back up. Make sense? Okay, so that's what's going on. This is an active instance. So as long as this guy's alive, this is like his heartbeat zipping through here. Okay? So this is displaying. Realistically speaking, internally, it probably recognizes nothing changed, so it's not going through the effort of displaying again, but it's certainly asking that question. All right, but since we just changed the state of that object, now it's actually displaying. Make sense? Okay, so we could write that in Java as well and have it constantly be threaded like that, but it would, now your program starts getting more and more complex. And I would say, generally speaking, threading is easy. So now let's throw in things like physics and crap like that, where you start appreciating what it is a game engine's doing for you. Okay. So what we're going to do here is, rather than when we click on the box, have it increase the number, we want clicking the box to make it rise. Okay? If we go into our blueprint for our actor, notice we only added a single attribute. We added this thing called mynum. But it has some other things. It has an attribute built into it called position. And position has an X and a Y. That make sense? So I can say that this guy's position starts off at Y200. So notice when I started, it lifted off the bottom. Similarly, you can come in here. Actually, I don't think it lifted off the bottom. I think that was already where it was set. Let me come in here and let me set Y to be 200 on that guy. We should see different. Okay, there we go. Now, notice something here. So both of these guys are down here at the bottom initially. These are both instances of this particular actor, right? In my Java program, when I said A1 touch, A1 touch, A1 touch, that particular instance's mynum variable increased, right? So his attributes belonged to A1. So A1 has their own collection of attributes. A2 has their own collection of attributes. Make sense? So since that's the case, even though I have my single blueprint here that allows me to define all the attributes that go into this guy, I can go in and I can edit the individual attributes of these guys over here. I can actually also define the individual attribute, the behaviors of a specific guy, and we'll talk about that later. But notice it has the little padlock thing there. Probably there's some ramifications to making some changes to that, and we'll talk about that. But notice that I can freely change the attributes associated with this guy. So what I'm going to do is, when we click on an actor, so we'll take away this display die guy there. When we click on an actor, we're going to go ahead and change one of his attributes. What attribute are we going to change? Instead of mynum, let's change his Y. So we're going to say change this actor's position Y to be whatever it currently is. That is, this actor's position Y plus 5. Make them elevate by 5 per click. Okay? So now we run this. Very epic. Put this on the App Store right now. Name it Flappy Birds 2.
Palm 2014.
It would sell like crazy. People wouldn't know.
Okay. Now, what's the third way human beings solve problems? Ask questions, but memory, variables. Asking questions, if statements. What's the third one?
Object.
Man, I could have made this this could have been a pop quiz. Repetition. Repetition. So we need to be able to have something happen multiple times.
I was going to say trial and error.
We have a couple of different ways to sort of kind of fake repetition in Game Salad. Now, I don't think it's fair to say that there's a one-to-one correspondence to repetition in Game Salad because you're actually creating a loop within the game loop. So try to disassociate repetition in Game Salad from repetition in Java at least somewhat. Okay, but we'll try to, again, it's like kind of like working within the matrix. So we'll kind of create an interesting facsimile, if you will. So we're going to come out here, and we're going to retrain our actors. We'll just go into the blueprint. We'll dump this guy. And we're going to go into our behaviors, and we're going to grab something called the timer. Okay, and we'll have this timer do something. You can either say every so often, after an amount of time, or for an amount of time. So I'm going to say every 1 second, we want something to happen. What are we going to have happen? We're going to change an attribute. We're going to change our actor's position, Y, to be whatever it currently is, plus 5. So every 1 second, each of these actors is going to get a little higher on their own. I'm not going to have to click on them or anything. This is version 2 of Flappy Birds 2. Flappy's Revenge. All we have to do is we have to add in our little we add in some scenery. Well, screw the scenery. We don't need that. You know, we'll just throw a pipe here in the middle, and then maybe put some in-app purchases stuff and some advertisements.
Vertical Flappy Bird.
And collect our collector. Actually, that wouldn't be a bad. That's actually not a bad idea for like a Flappy Birds 2. Have it almost be almost spaceship-y type game where you're flying upwards and the pipes are coming at you this way and you're going side to side to miss the pipes. You see what I'm saying?
Yeah.
And maybe at the bottom you have a slider that's making your guy slide between. So instead of tapping like that, you're like being twitchy like this, but as you go farther, maybe the pipes come at you faster. Man, gold. That is the type thing that actually would sell.
Yeah. So very well. Want a fundraiser for the CS?
Oh, wait, we lost our guys. Okay, so that makes sense?
Yep.
All right, so now we have stuff happening automatically. We started our program. So through repetition, every 1 second, something's happening. Let's mess with this repetition a little bit more. Let's throw another timer out here. Actually, just for the sake of sanity, I'll just, since we had the issues last time.
Sanity, what's that?
I'm gonna throw another timer out here, and we're gonna say let's do something for, let's say 5 seconds, 6 seconds, because that's what I clicked. All right, and inside that timer we'll put another timer. And in here, we'll say every 1 second, do something. What are we going to do? We're going to change an attribute. We're going to change this actor's position on Y to be its current position plus a random number between 3 and 9.
This could be dangerous.
Curveball.
All right? So, for 6 seconds, these guys should be taking off. It's kind of like the Russian shuttle program. Should be taking off at a little bit different rates. It's a little Sochi humor, right?
Yeah.
Okay, so we'll run this. Think the guy on the right's winning by a little bit?
He was.
No, we ran out of time. So let's give him a little bit more time. Let's do it for 20 seconds.
Got $10 on the left.
He's like, all right, take your bets over here on the left. All right.
Right's taking off.
Big money, no whammies.
Oh.
No whammies.
I call hacks.
It's doing the best Buzz Lightyear impression.
All right. So, for Monday, create a duplicate of this little game we just created. What I want you to submit is a screenshot of your actor's blueprint. This guy here. Okay? So, if you're on a Mac, you can hit Command-Shift-4 and highlight it, take a picture. If you're on a PC, print screen usually works, or
Alt F12.
Alt F12. Make sense? I'll put the assignment up on Angel, but that's your assignment for Monday. Start using Game Salad.
Can we throw images on